Now that we know how to identify a GCF, we can talk about how to factor out the greatest common factor. Now the idea of factoring out a GCF is almost the reverse of the distributive property. We're going to be identifying the GCF and taking it back out of every single term, pulling it outside a pair of parentheses. For example, if we have the polynomial 2x plus 16, and we want to factor out the greatest common factor. The first step is to identify the GCF. Well, in this case, it's easy to find. The common factor between 2x and 16 is 2. So we're going to take this common factor and factor it out, meaning we're going to divide it out of the two pieces in our polynomial, and that common factor gets written as a coefficient in our set of parentheses. So 2x factoring out or dividing out the 2, we will be left with x. 16 factoring out or dividing out the 2 will leave us with 8. So this expression has the greatest common factor of 2 factored out or pulled to the front of a set of parentheses, and it has been pulled out of both of the terms. If we wanted to check our answer, we could take this 2, that's the coefficient, and distribute it through the set of parentheses. Distributing that 2 back through the parentheses would give us 2x plus 16. So this is an equivalent form of the original expression, simply with that common factor factored out or pulled to the front. Another example would be 24 x squared y to the third plus 32 x y squared minus 40 x squared y. Again, we need to look through these three terms and identify the greatest common factor. It must be identified before it can be factored out. Start with your coefficients, 24, 32, and 40. 8 is the largest term that is a factor of all three of them. Then look at your variables. We have an x squared, so an x and an x. We have an x, and then we have another x squared. Look for what is common. There is an x in all three of those. So x is part of our greatest common factor. Now look at the y's. We have a y to the third, we have a y squared, and we have a y. Again, we're looking for something that is common, something that is in all three of our terms. Well, there's a y in all three. So that's part of our greatest common factor. Our GCF here is 8xy. Now that it has been identified, we can factor out that greatest common factor. To determine what's left inside our parentheses, we take each term and divide out the 8xy that is being factored out. So 24 divided by 8 would be 3. X squared divided by our x would leave us with x. Y to the third divided by y would leave us with y squared. Go to the next term. 32 divided by 8 is 4. The x dividing by the x will leave us with no x at all. This x is being pulled out of the parentheses. The y squared dividing out the y would leave us with a y. And then lastly, 40 divided by 8 would be 5, and it's going to be a negative 5 because that was negative 40. X squared, factoring out an x, will leave us with an x inside our parentheses. We had a y, and we're factoring out a y, so there's not a y left inside our parentheses. So this is the factored form of our original polynomial. Again, if you wanted to check the answer, you could do so by distributing. 8xy times 3xy squared. 8 times 3 is 24. X times x is x squared. Y times y squared is y to the third. So far, so good. The second piece, 8xy times 4y. 8 times 4 is 32. X, y times y is y squared. Almost there. Lastly, 8xy times negative 5x. 8 times negative 5 is negative 40. X times x is x squared, and the y. This is the same as our original polynomial, so we're good. We correctly factored out the greatest common factor.